Hello students, this is Mr. Yang. In this lesson, we are going to continue to learn more about features of exponential function graphs. In previous lessons, we have learned a few different things about the exponential function. We have learned about the forms. We have also learned to generate the exponential function graph by plotting. So let's quickly go over these again. Function form. f(x) equals a times b to the x power plus c. b is greater than 0, and b cannot be 1. That's the requirement. Then we also define those few things in the function. A is the initial value, b is the growth or decay factor, c is the vertical shift. B is the one that's actually going to affect if it's growing or decay. But A also plays a role, so you can't exactly just think, oh, it's always going to be greater than 1 or less than 1. We're going to look at the graph if it's increasing, which in other words, it's going up that way or that way. That's growing. Decaying is going down. And vertical shift is typically where the asymptote is. We have also learned to use our calculator to help us plot exponential graphs. Press y equals and type in the function. We're going to use a little caret key to type in functions, and then press second and graph. That's actually to give us the table so that we can actually use the values. Now let's get into the examples. Example 1. First, we're going to need to graph the function. So let me pull up the calculator. One thing to remind you, first make sure you click mode, go down. And again, this only works for a TI-84 calculator. If it's a TI-84 plus, if it's a TI-84 plus CE, it actually doesn't have this function. You are going to get decimal answers. So when you get two answers, go to fraction, click on enter. That's going to set our answers to be fractions. You can either click clear or put second mode to quit it. So clear. Now let's actually type in the function. 4 times, don't forget the parentheses, parentheses 3 divided by 2, parentheses back, little caret key, then the x, get out of the exponent, then minus 4. Second graph. That's going to give us the table with the values that we need. I'm going to press the up arrow to actually get to the negative numbers. So -2, -1, 0, 1, 2. The values we have, -20 over 9, -4 over 3, 0, 2, and 5. Next, we are going to graph. -20 over 9 is a bit over -2. So that's below -2 when x is -2, so around here. And then -1 is corresponding with -4/3. That's a bit over -1, so it's around here. Next, 0 is with 0, 1 is with 2, and 2 is with 5. So you can clearly see on the other end, it starts to grow a bit faster. And we're connecting with a smooth graph. So there you go. That's on the other end. As for the left end, typically the part that is going almost flat, we do need a bit more information to be able to identify exactly where that is. So let's actually go over a few of the features. Domain, quite easy. Negative infinity, positive infinity. That's always the case. The rest, well, let's start with the initial value factor and vertical shift, because as soon as you see a function, you can easily identify these things. Let me write the function form on the top again. f(x) equals a times b to the x power plus c. A is our initial value. It's the number in front of the base and the exponent. So in this case, initial value is 4. Factor is the base that has the exponent x. So in this case, 3/2. Vertical shift is the number on the end. So in this case, -4. Vertical shift is quite important because vertical shift will actually help you to identify the range and actually end behavior as well. And also vertical shift is where the asymptote is. So in this case, we know the asymptote is actually going to be y equals -4. So let's actually draw that on the graph to indicate, oh, this is the line that is actually never crossing. And as soon as we draw the asymptote, we know what happens on the left end for this graph. It's going to keep going down, and it's getting close to -4, but it never crosses. So now with that, we can actually write the range. Because the range typically starts from the vertical shift or starts from the asymptote, since it's never crossing or touching the asymptote. So it's -4 to infinity. As for the y-intercept, from the table, you can already identify the y-intercept, which is at 0, 0. growth or decay from left to right, we can see our graph is increasing, so it's going to be growth. We can now write the end behavior as x approaches negative infinity. That's our left end. We can see it's actually getting close to 4. So f of x approaches, it's approaching negative 4. And then on the right end, as x approaches infinity, f of x approaches positive infinity. So that is everything for example 1. It's going to be a bit of a process, go through the graph and all the features. Now I'm going to ask you to pause here and try example 2 and 3 by yourself. Then you can come back and check it. Now hopefully you have tried it. Let's have a look at example 2. Same thing, let's graph it first. You can either choose to type it into y2, or you can just clear everything from y1. Let's type it in. Negative 2 times 3, little caret button, to the x power, get out of the exponents, and plus 4. For a second graph. The values that we need are right there. Negative 2, negative 1, 0, 1, 2. Y values, 34 over 9, slightly less than 4. 10 over 3, a bit over 3. And then 2, then negative 2, then negative 14. Let's graph it. Negative 2 is with 34 over 9. So again, that is almost to 36 over 9, which is actually 4. So it's a bit less than 4. And then we have negative 1, 10/3. Next one is 0, 2, 1, negative 2, and 2, negative 14. So you can clearly see on this end is going down pretty fast. So you know what's happening on this end. As for the other end, we may want to go through the features to actually identify exactly where the asymptote is. So domain, always easy, negative infinity to positive infinity. Then let's identify the initial value factor and vertical shift. A times b to the x power plus c. So initial value is at negative 2, factor is at 3, and vertical shift is at 4. Okay, now that we have written those down, from the graph, you can clearly see it's going down. So it's decay. The vertical shift, again, is going to tell you the asymptote, is also going to tell you the end behavior. It's actually also going to help with the range. So vertical shift is at 4, which means we're going to draw a horizontal line at 4, a dotted horizontal line. And we now know on this side of the graph is going to get close to 4, but it never crosses it. Okay, so asymptote is at y equals 4, and the range is going to be, in this case, we have everything below, so it actually starts from negative infinity until 4, which is the horizontal asymptote. As for the y-intercept, it's in your table when x equals 0. That point is 0, 2. And behavior, as x approaches negative infinity, this case on the left side is not going over 4, so f of x approaches 4. Next, as x approaches infinity, f of x, it keeps going down to negative infinity. That is example 2. Now let's move on to example 3. Same thing, let's use the calculator to generate the graph. To generate the value so that we can draw the graph. Y equals, you can clear, let's type it in, 3 times parentheses 1 divided by 3, parentheses back, little caret button to the x power, get out of the exponents, and minus 3. Second graph. Now we have everything we need. Negative 2, negative 1, 0, 1, 2. Numbers 24, 6, 0, negative 2, and negative 8/3. That's over negative 2, close to negative 3. So let's put the points down. Negative 2 is actually at 24, which is a bit above. 1, 2, 3, 4. That's like kind of where it is. Right there. Then negative 1 is at 6. 0 is at 0. 1 is at negative 2. And then 2 is at negative 8/3, which is close to negative 3. So there you go. At least on this end, pretty clear what is happening. Is coming down. Let me actually draw the curve a bit smoother. As for the other end, what we know is going to get to that value. So let's actually identify some features to be able to complete the graph and find out more about that one. Domain, negative infinity, positive infinity. Let's identify the rest. Initial value, a is a times b to the x power, plus c. Initial value is 3, factor is 1/3, and vertical shift is -3. And again, the vertical shift is going to help us to identify the asymptotes, the range, and the end behavior. So vertical shift is -3, which means the asymptote is y equals -3. Let's draw the line, the dotted line, at -3. We would also know on this end is actually approaching -3, which is never crossing it. You can clearly see from left to right, the graph is going down, it's decreasing. So that is going to be decay. With the asymptote, we also know the range. There's nothing below -3, but it has everything above. So it's -3 to infinity. And behavior, as x approaches -infinity, on the left end, it goes up forever. Fx approaches infinity. On the right end, as x approaches infinity, fx approaches, well, it's never crossing -3, so it's approaching -3. As for the y-intercept, right here, 0, 0. And that is example 3, and that is everything for the second lesson of features of exponential function graphs. Thank you.